Hi, my name is Rebecca Unetic, Director of Strategy for Fuse Integration, here to discuss the Tactical Communications Management Processor, or TCMP, Phase 2 SBIR for NavWar. Fuse is a service-disabled veteran-owned small business focused on network and software solutions. Fuse focuses on developing solutions with the warfighter or end user in mind. Imagine you're a military platform operating in a highly sensitive area, and you determine your links are becoming degraded due to operating forces using electromagnetic countermeasures. With OSPF, you have no recourse for singular IP link failure. However, with TCMP, your data packets are sent over multiple links and then consolidated with data from each link. This allows for robust and resilient communications, which is vital for warfighters delivering time-sensitive payloads or highly sensitive information. Having a singular link as a source of communications failure is an issue for all joint forces and causes unnecessary limitations across disparate data links. However, the ability to send your data across multiple link paths concurrently, i.e., break the glass scenario, guarantees resilient communications. That's what TCMP affords the warfighter, even in the most electromagnetically contested environments. The most important thing to note about TCMP, beside its resilient operating capabilities in even the most extreme degraded network conditions, is the fact that it can work on ADNS and other DoD network architectures. Right now, we are still putting the finishing touches on final software features while completing testing in a live virtual constructive environment. The initial build is to be completed in Q1, fiscal year 24, and starting preparation for fleet experimentation in February 2024. Lastly, as you can see on the right, in a network-degraded test scenario, TCMP closely follows its theoretical max and outperforms OSPF by 2 to 3-fold, all the way up to almost complete network degradation. During the second SBIR option period, we finished the final touches of transport protocols and cross-domain network security architectures, as well as configuring communication delivery logic. Overall, the end goal of Phase 2 has been to deliver a fleet testing-ready solution that will run over legacy DoD network architectures, with a delivery date of February 2024. There are additional advantages to TCMP over legacy DoD network architectures. TCMP has demonstrably better throughput compared to OSPF. This advantage only increases the more IP links that are enabled. Also, TCMP takes less time to transmit resilient communications in the event of issues compared to OSPF. For example, if OSPF fails to send data packets over a single path, it will continue to take time to retransmit until it finally gets through. Meanwhile, TCMP uses the fastest and most efficient methods to transport data packets, and then backfills any missing data gaps with subsequent received packets. The end result is a more resilient communication system that will save the military considerable money due to not having to run redundant communication systems. PMW 150 has been the advocate for this solution, as it is being developed for a fleet testing solution by the end of this Option 2 period, February 2024. This capability could be applicable to additional airborne, surface, and subsurface platforms. Fuse is also currently coordinating additional avenues to deploy this solution. Any user that is looking to update legacy DoD network architectures and/or manage communication systems for tactical platforms operating in contested communication environments, or require high-fidelity communications for high-priority data transmission, would greatly benefit from this solution. Users aiming to modernize legacy DoD network architectures, oversee communication systems for tactical platforms in contested environments, or those in need of high-fidelity communications for high-priority data transmission, can significantly benefit from this solution. The most significant benefit of this solution is the demonstrable increase in probability of communications. This marked improvement far outweighs the minimal short-term drawbacks such as operational downtime and costs of installation. We are currently working with the Navy to test in an operational relevant exercise, which would elevate the technology readiness level to 7. Also, it is important to note that the TCMP technology is a purple technology solution. In other words, it is military branch agnostic and should work with any platform or weapons system. Specific opportunities to test this technology operationally with the Navy include Valiant Shield or RIMPAC. Another potential opportunity is to test it in a maritime operations center. The targeted end users for this software include war fighters looking to update legacy DoD network architectures, manage multiple tactical communication systems, and operate in electromagnetically contested environments.